All right, so now let's start talking about what happens when matter changes from one phase to another, right? So as you see here, from a solid to a liquid to a gas. And again, plasma, but we're not going to focus too much on plasma, right? We're going to kind of talk about what happens when they go from one phase to another. And these are things you see every day, right? You see ice cubes melting, you see water boiling, but what is the actual science behind it, right? Why does it do what it does? And so we're going to be learning about is just what happens again when it goes from one phase to another. So from a solid to a liquid to a gas to, and again, not plasma, I guess. So mostly solids, liquids, and gases. And what the heating curve is going to look like on a graph. So basically, like at what temperature and what time does it turn into a solid? And then at what temperature and what time does it turn into a liquid? And then at what temperature and what time does it turn into a gas, right? So that's what we're going to be seeing on a graph in a little bit, mostly focusing on water, right? So ice, liquid water, and then steam. All right, so just a little bit. I mentioned kinetic molecular theory in the last class, or kinetic energy. And so all that means is kinetic molecular theory. Remember, molecules, and we're going to learn more about that, are just like the building blocks that make up matter, right? So a lot of times it's two or more atoms together. And I'm not going to get too much into that, but basically we will get into it later. But for now, just know that kinetic molecular theory means that everything is made up of tiny, constantly moving particles, right? All matter is made up of that. And the kinetic energy, again, the energy of motion, it increases as the temperature increases. So that means as you turn up the temperature on something, the particles are going to move faster and faster and faster. And I remember an example that from as a kid that I remember is someone left a can of paint on a heater at my grandmother's house. And it was an old school heater and it got really hot around the edges. If you touched it, you would burn yourself. But anyway, someone left a can of paint on top of it with the lid on. And when it was getting hot, when it got heated, the particles inside of the gas can were moving around so fast. And so they needed somewhere to escape, right? Because they were trying to separate from the other gas particles as much as possible. And what ended up happening was that the can of paint just popped open. The lid just flew off and paint just splattered all over the living room. Right. So that's what happens. That's why you don't want to put like a can of bug spray or like hairspray or something on heat, because eventually like the particles have nowhere to go if it starts heating up and it will just explode and shoot up like a bottle rocket. Right. So the more heat you give something, the more the particles try to spread out. And if you don't give it enough space, it can actually blow up in one of these containers. Right. So don't ever put a can of paint on top of a hot surface. Right. But in this case, it says as a result, ice has less kinetic energy than water, and water has less kinetic energy than gas. And just a hint, that kind of sounds very similar to a possible midterm exam question. So here you see on the very right, solid has the least amount of energy, and then you give it a little bit more energy, and it starts to spread out a little bit more into a liquid. And then when you give it enough energy, it takes the shape of, or sorry, it spreads out completely, right? And it takes up the whole shape of its container. So it actually, you can see its increased volume and it's taking the shape of its container. Liquid, again, it takes the shape of its container, but its volume doesn't increase. Solid, it keeps its own shape, right? It doesn't take the shape of its container. And solid is the particles are very tightly packed and it does not grow in volume.